Aloha. You're watching F5 On Demand. I'm Senior Technical Marketing Manager Peter Silva. We're here in San Francisco for RSA 2014 at the Moscone Center in booth 1801. If you're at the show, please come on by. Earlier, we announced our new web fraud protection solution, and I have Mark DiMinico with me today. He's a field systems engineer. Thanks for joining me, Mark.
Great to be here. Thanks for having me.
First time on the show, eh?
It is, absolutely.
You're excited, aren't you?
I am. It's great to be here.
So I thought we would get with Mark and get a little inside scoop and maybe even a demo of our new web fraud protection. And right here I can see anti-fraud, anti-phishing, and anti-malware. You want to take us through this a little bit?
Sure, absolutely, sure. So this was really announced this week, and what we're providing is an additional security service as part of F5's overall security portfolio, and it's really focused in on web fraud protection and detection, protecting the end users and giving visibility to malware and threats that might be on the end user's device, very early detection in real time of those threats so that we can give our customers early visibility into those type of threats that are out there on those endpoints.
Got it.
So really what we're focusing in on is on the actual devices themselves, we're pushing our solution out to 100% of the users that deploy our solution, which is very different from other solutions that are out there in the market. Other solutions require you to download and install something on the actual device. We don't require any installation. We deliver our solution as part of the web application.
Got it.
So it's unique in that it's 100% of the user base, and it's also completely transparent to the end user.
And does it apply across both, internet-facing and intranet web portals?
So we really focus in on internet-facing because that's the majority of where the threats are,
yep.
The malware threats. But you can deploy it internally if you have concerns internally about your employees accessing internal portals that might have malware on those devices that are accessing them.
Yep.
But the majority is internet-facing devices.
Got it. Okay.
So really the main focus of the solution is we detect malware, both targeted and generic malware. So that's your Zeus, your Spy Eyes, all the generic financial malware that's out there. And we also protect against man-in-the-middle, man-in-the-browser, and some advanced phishing attacks.
Oh, wow. That's pretty cool.
So what I'll do is I'll walk you through a quick demonstration.
Okay.
What we have set up here is a demonstration site that really has three main pages that we're looking to protect. The first is the login page, which is usually where our customers deploy the solution because you're covering 100% of your end users before they authenticate into your system. So we can identify right off the bat if you have malware on the device and actually raise the risk score of that device and gain visibility to really any of the users that are going to authenticate in your system, determining what's on that device, if there's anything malicious on the device. The second is we have a transaction page, which we're going to be protecting as well.
Okay.
So after authenticating, we protect against automated scripting attacks that might occur.
And I've seen some of those, like say with banking apps, where you're able to get in and you have that active session going and they're able to steal the credentials and then repost and get to your site.
Exactly. So that's what we protect against post-authentication as well. And then the last piece that we're gonna protect against is the account summary page. So very, very advanced malware will sometimes actually do an automated transaction behind the scenes and then, unbeknownst to the user, actually change some of the account balance information that's being displayed to the end user so that when they look at their account balance, they may have had funds removed or sent to a mule account, but they don't actually see that transaction in their account summary page. So some pretty advanced malware threats will protect those account summary pages as well.
That's pretty sneaky, isn't it?
It is. It's pretty advanced stuff. So let's go ahead and jump right into the demo.
Okay.
So again, as I mentioned before, what we have here is, this is a demo site, and really what we've done is we've deployed our detection and our protection on our login page, our transaction summary page, and the actual page that's performing the transactions themselves. Okay. So how do we protect against malware threats that are out there? Well, first is detection. The first is trying to understand what the risk score or what the threat might be out there that's on this device. So as part of that, what we do is we can detect generic malware and targeted malware that's on a device. Really what we're doing is we're looking at the content of the page as it's being delivered through the big IP device, through the F5 device, taking a snapshot of what that page should look like when it's rendered on the device, and then comparing it to actually what it appears when it's rendered on the device. And taking a look at those two snapshots and being able to determine if there's been any injections done, any change to content, things like that that'll help us identify if malware is on the device.
That instant differential. And
Exactly. So what we'll do is we have a little demo tools that I'm going to pull up that'll help us mimic what malware does on a device. I don't have an infected device here for demo purposes, so really what we're using is our demonstration tool to show how that's done.
Sure.
So typical malware will inject JavaScript or any type of additional input values to try and present the user with additional information that it might be asking for. So in this page, you have your username and your password, but malware might inject something like credit card number, one-time password, things like that to grab information. They also may inject some JavaScript that'll actually go into the page and add an additional pop-up. So what we're doing here is actually we're going to demonstrate what a injection might look like. And we're just going to inject an additional script reference into the browser's DOM. When we do that, you'll notice that nothing really changed from a user's perspective. They didn't see anything occurring. But unbeknownst to the user, we've actually sent a silent alert behind the scenes in real time, notifying our customers that there's an injection that was done. We tell exactly what that injection was, so what was the script actually doing, the IP address of the user where this injection came from, simple device ID information, very powerful information to get an idea of what's actually on that device and what was that malicious activity actually doing. So I'm going to switch over here. This is our alert dashboard, which actually consumes all the alerts that are issued from those infected machines. And this will give you visibility to exactly what's on those devices from a malicious script standpoint.
And this service is available on all big IP platforms?
It is. So required for certain functionality, there are certain hot fixes that are required in order to run this. But it's basically just an iRule and a set of data groups that you configure, apply it to a VIP, and then you're up and running with the protection and detection mechanisms. So you'll see here that on the left-hand side, you have the phishing and malware alerts that come across. What we did was we injected a malicious script. Yep. So you'll see here that we have one notification. Let's go ahead and click on that. You'll see that this will list all of the injections that have occurred on this particular site. You'll see that this here is www.malware.com inject.js. That's exactly what we injected into the web application. This has a severity level of 50%. And it gives you some information as far as refer, language, IP address, timestamp information. Very, very useful information from a forensic standpoint to determine what is actually occurring on the device.
Yep.
So that's our targeted malware detection. We're also able to detect generic malware like Zeus and SpyEye and Carberb, all the generic malware out there. And those alerts come across very similar to these but we'll actually identify the exact variant of malware that's on the device.
And earlier when you were talking about risk of the device, that equates to this severity, the 50%?
That's correct, yep. And there are ways within our alert dashboard to actually set the severity depending on rules that you can configure. So if there's a set number of IP addresses that you want to escalate alerts that come from, specifically, you can actually set up rules within our dashboard that allow you to, okay, if you receive an alert from IP address X, then go ahead and escalate that severity to 100%.
Yeah.
So there's different ways that you can actually set up rules within the dashboard to allow you to escalate or even ignore some of the alerts that come across.
Yeah, because within each company, their various risk levels may differ based on other companies in different industries, and so those can be adjusted for whatever reason.
Exactly. Yep.
Interesting.
Yep. So that is our ability to detect malware.
Okay.
Now, unique to our solution is the ability to protect the end user without having them require any download or installation. Mm-hmm. As I mentioned before, typical solutions out there will require you to download something that'll scan, look for signatures, and try to remove malware. With our solution, you don't have to install anything. It's a seamless, 100% user transparent solution that allows us to even protect against things like man-in-the-middle, man-in-the-browser attacks. Mm-hmm. So what we actually do is, let's go back to the demonstration site. What we have enabled on our password field is our protection mechanisms.
Okay.
And what we do is we utilize RSA, public-private key protection, to encrypt information in real time as it's being entered in by the end user. So typical malware out there that's trying to steal credentials or steal personal information will use form grabbing because it's highly scalable, return on investment is extremely high. It actually takes all the information of the posted messages, no matter what site you're accessing, and sends it to a drop zone where it's processed and allows you to allows these fraudsters to log in and actually look at this information just like a normal search engine. So if they wanted to view, how many users do I have that were infected that visited Gmail, and what username and password did they use? It's very simple for them to log into these drop zone portals, these command and control centers, to actually pull up that information and grab that. So how we actually protect, again, is we encrypt that information in real time. Okay. So we don't have our protection enabled on the username field. So I'm just going to pull up Chrome's developer tools and show you how simple it is just to pull the username information. So just using simple JavaScript. You can actually see that we just pulled the string that I had entered in username.
Yep.
Now, because we're protecting the password field, if I start typing 1, 2, 3, 4, 5, 6, 7, 8, which is the password here, highly secure, and we do the same thing on the password, you're going to see that we've actually encoded that information.
Ah, yeah.
So this is actually a masked value.
Yep.
But we have actually added in a fully encrypted 1024-bit RSA encrypted value of actually what I've entered in there. So when I submit this information and I post it to actually log in, and we look at the network traffic and what is actually posted as part of the value here, you'll see that here's our username, which we're not protecting.
Yep.
You can see that in clear text. And here's the information that's actually in the password field.
Wow.
This is the information that's sent to the drop zone.
Yep.
And because we're protecting that, because we're encrypting it in real time, it allows us to essentially, it doesn't really matter if malware is on the device and stealing this information, because the information it's capturing is in encrypted format now.
Yeah. So come back to the site, try user and
Exactly.
Denied.
Not going to be able to get in.
Yeah,
exactly. So,
and it's kind of important, we're doing the various steps. They might not have malware on that initial, so they're clean bill of health. Mm-hmm. You can enter your username, but in those milliseconds, they can still get infected to try to then steal the password, wouldn't they?
Exactly. Yeah. So an infection can occur any point in this process.
Right.
And our assumption is you have to assume that every single endpoint is infected or will be infected at some point. So that's why we provide this level of protection across all the end users. We're delivering our solution as part of the web application. We're actually injecting our code as it's coming through the big IP device. Yep. And then delivering it to 100% of the users to allow our protection to be across the entire user base.
That's cool.
Yeah. So that's how we protect.
Okay.
This also protects against things like man-in-the-middle attacks. So if I was to capture this information using some sort of proxy server, the information that I'm actually going to see is this encrypted information. So for an end user to try and capture that information and then try to submit it, change something like an account number to send it to a mule account if we're doing a transaction, they're not going to be able to do it because, one, it's encrypted, and two, if they try to change this value to something that the server is going to, or the big IP is going to be able to interpret, it's not going to work. It needs to be in fully encrypted information for it to work.
That's cool.
Yep.
It's interesting, too. There used to be this notion of, trusted internal versus untrusted. And in the last couple of years, it's just like everything is untrusted. I don't care who you are.
Exactly. And that's the assumption that we make, is that every device that's going to be accessing, assume it's untrusted. Yep. So how do you protect the transactions? How do you protect the personal information? So one of the additional pieces that we provide is transaction protection.
Yep.
So we're able to differentiate between a human and an actual script that might be doing a transaction. So on our transaction page, we have our automated transaction protection enabled. And what it does is it's actually capturing mouse movements, keyboard depressions, the velocity of the transaction, the location at which the user is actually clicking on a field value to enter in information, because malware can't simulate, a click on X 100, Y 250. It needs to, the way malware actually captures, or the way that malware performs those, will actually show as a 00 pixel location when it enters that in. So we take these positive and negative behavioral values, and based on that information, we can differentiate between an automated transaction and a transaction that's being done by a human. So if we go ahead and we're going to enter in an actual transaction as a normal end user would. Let's go ahead and enter in account 1, 2, 3, 4, 5, 6, 7, 8.
That's crazy. That's my account number.
It's mine too. That's weird. We'll do $100, and then we'll enter our actual one-time password. So again, what our solution is doing is it's capturing all this information. When I hit submit, you'll see that here's our transaction that came across.
Yep.
That's good. Now, if I go back into our alert dashboard, I shouldn't see an alert here, which is good because it was an actual human doing the transaction. Now, if I go back to our transaction page, and I'm going to do this relatively quickly because I want to trigger this under 5 seconds, I'm going to go back to the transaction page, load up our demo tools, and submit an automated transaction. So demo tools, automated transaction, let's go ahead and hit enter. So you'll see that it populated with a whole bunch of 7s. But
a whole lot more money too.
Exactly. So what our solution has done is, if I go back to our dashboard and we refresh, you see that we now have one automated transaction alert that comes across. And it has a 70% severity because there's a few reasons. One, it took 4 seconds instead of our configured 5 seconds, so that was the velocity check.
The threshold.
Exactly. And it also identified that there was no mouse click and no enter key.
Now that's pretty cool right there.
Yep. So with that combination, you can actually configure the different thresholds within our solution using our data groups. So you can say, if I want this velocity of a transaction on this page to be at least 5 seconds, you can configure that velocity threshold.
So then what, that $777,000 transaction does not then get completed by the bank? Is that how it works?
So we have this in really monitoring mode right now, but because this is implemented through an iRule, and we have this information as it gets back to the big IP device, we can block that transaction. Or we can reroute it for, further information, for example, or, integrate.
Or additional scrutiny from a human to say, okay, this doesn't look right, or it is right, you just happen to be a fast typer.
Exactly. Or you can send it to a queue where, depending on what the policy is of our customers, there's a number of different things that we can do. So this is, and you'll also notice that we also capture the username. So once a user's authenticated, we know their user ID, we know the IP address they're accessing from. So this is really a single location where our customers can go and say, give me a list of all my infected users, or give me a list of all those users that had some suspicious transactions occur from that. So that you can actually use this information and feed it into the overall fraud ecosystem of our customers. Our solution plays very well with existing fraud solutions or risk management solutions that the customers might have.
And it really seems like you can, essentially enable this on a big IP, and it other than a few of the risk levels and other, specific metrics to your company, this could pretty much be working rather quickly, right?
It is, yeah. So you can get this up and running in a matter of days. So it's not weeks. Yeah. Usually from a proof of concept standpoint, we're able to implement in and usually between 3 and 5 days. So that's actually configuring a solution, going through a full set of tests and verification, and then handing it off to a customer to go off and test on.
So by the end of the week, you too can be protected, right?
Exactly.
This is great stuff, Mark. I really appreciate it.
Sure.
It's the first time I've seen this demo. It's quite impressive.
Thank you.
Yeah. So a little bit more there for our anti-fraud, anti-malware, the web protection, really, right?
Exactly. Yeah. And there's more that we didn't get to, but this is just scratching the surface.
Excellent. Thank you very much.
Sure.
So a little bit more on the new solution from F5 here at RSA. And so for Mark, hey, thanks for joining me.
Sure. Anytime.
Right on.
Yeah.
I got Jay behind the lens. I'm Peter, and we're with F5 Networks. Thanks for watching.